Okay, so this is homework 7, number 3, where we have to make a Bode plot. And first they give us the initial transfer function, 10 over 10s plus 1 times 4s plus 1. And basically you can split that up into 3 separate transfer functions. So the first one being 10, so t1s equals 10. And to transform that with w, so we can use the frequency in the Bode plot, it would just be the same, so it would also equal to 10. And here we have t2, which would be 1 over 10s, which is just the first part from up here. And that would just be 1 over 10w plus 1. And t3 follows the same kind of suit, so it would be 4s plus 1, or 1 over 4s plus 1. And then t3 with respect to w is 1 over 4w plus 1. And by inspection, you can see that w2 would be 1/10, and then w3 would be 1/4. Okay, and then you want to find the magnitude of each one and its respective angle at the different frequencies. So for the magnitude of 1, it's just 20 log of 10. There's no w, so you don't have to worry about it changing. So it's just 20 decibels. And then the angle is the angle of 10, and any angle of a constant is just 0 degrees. For the magnitude of the second one, it's negative 20 log of the magnitude, which would be 10 jw squared, but since the j squared would just be 1, you can take that out, plus 1 squared, all under the square root. So that will change with respect to the w's. And then its angle would be the angle of the 1, which would be the numerator, minus 10 jw plus 1. And since that's a constant also, it's 0. So you just get negative 1 plus 10 jw for your angle. For the magnitude of the third one, just like in the second one, it's negative 20 log of the magnitude of square root 4w squared plus 1 squared, j dropping out again. And then the angle, just as with angle 2, it's just going to be negative the angle of 1 plus 4jw. And so now using these values, we can create our plot, or our table first, I guess, and then we can plot it. So for our table, for M1, it's just going to be 20 decibels all the way across. So just a flat constant line, and that's signaled by the red line here. So with MW, or the MW plot with respect to W, it's just going to be one constant line, and same goes for the angle, so that is just 0 all the way across. The second one, M2, you're going to start at 0, and then you're going to end up at negative 20 decibels from 110 to 1/4, and then actually you're going to end there too. So if you go here to 120, so you got 0 all the way to 1/10, from 1/4, or from 1/10 to 1/4, then you have negative 20. So that is signaled by our blue line here. And then for the angle, you start out at 0. When W is 1/10, the angle is going to be at 45. And then from 1/10 to 1/4, the angle is going to be negative 90 and stay there. So that's also by the blue line in our, so we have 0, and then we go from, we go up to 45, so that's our 1/10, and then from negative 45 to 1/4, we get up to 90, or negative 90, and then it's constant all the way across. For the third one, it starts out at 0, it continues to 0 from 1/10 to 1/4, and then at the end, it goes to negative 20. So that'll be signaled by our purple line here. So we got 0, and then we'll jump to 20, and we'll keep heading out in that direction with that general slope scheme. And then for our angle, it's actually going to be 0 and 0, just like the magnitude, and then it will be negative 90. It'll jump to negative 90 and stay there. So when we go to our angle, so we got 0 all the way across, and then once we get to 1/4, it'll jump to negative 90. Actually, I'm sorry, I drew that wrong. This is 0.025. This is 0.25. So it should be here, and then it should